All right. Last session before lunch break. Next up is Mika Naylor. She's giving a talk about why code styles are not black and white and maybe more colorful than just these two. Give her a warm welcome and round of applause. Thank you.
Thank you, Marcus. I'm Mika. I'm a developer based in Berlin. And today I'm going to talk about something very close to my heart, which are code styles. We all encounter them kind of consciously or not, and they're kind of quite important. Oops, let me just... Sorry. And they're all kind of important in our day-to-day lives. But what are code styles? They're a little difficult to pin down. I like to think of them as a kind of set of idioms and techniques and conventions that we all either consciously or unconsciously use when we write code. And this kind of cuts across languages. Some languages are more prone to having variable code styles. Some are more strict about what you can write. But generally, how you write code as a code style is kind of important no matter what language you're writing in. But importantly, code style changes how the code that we write looks, but not what it functionally does. Ideally, code styles should be transparent to whatever process is responsible for either compiling or interpreting the code. The same code written in different styles should be the same thing to, for example, the Python interpreter. Ideally, a good code style should be one that aids our immediate ability to read and comprehend a piece of code as a text, not understand functionally what it's doing, but just so that we can read it as we might like read a book. It should allow us to register what is actually going on with minimal effort, so that we can focus on more important things like understanding the actual functional content of what's going on in the code. To illustrate kind of just how important the most basic code styles are, I'm going to use an example in Python and, in Java, sorry. Bear with me because I'm doing this because, for one, I want to illustrate how important this is across different languages, and also you can write messier code in Java, which is kind of what I want to do. The example that I'm going to use is matrix addition. For anyone who doesn't know what the matrices are, they're essentially a 2D array of numeric values, and when you add two of these matrices together, you get a resulting matrix of the same dimension, where each value in each position is the sum of the values in the same position in the two input matrices. Okay, so let's get started. So first, in Java, we want to write our boilerplate main function. This is all in one line, by the way. It's just line breaking. It's all in one line. And then, yes, we want to initialize our first matrix with some values, and then we want to initialize our second matrix with some values, and we want to initialize our sum matrix. Next, we will do a for loop over the first matrix, just as a kind of length thing, and then we'll iterate over each element in that row and add what is in that position, I and j, from both matrices to the sum of I and j, and then we'll close off the for loops. Now that we have our result matrix, we will iterate over the sum matrix, first each row, and then each thing in each row, and we'll print it out to the console, padded by some spaces so it looks nice, and then we will then, after each row, print out an empty line just so that it looks all nice and neat. And then we'll close everything off. Now, if you were working on some Java code in your day-to-day life and you came across something that looked like this, would you be particularly happy about seeing it? Probably. I heard yes, but probably not. Yeah, what it's doing functionally is not super complex. It's just iterating over some stuff, but as a text, it's unreadable. You could spend ages trying to read this without understanding it. But if you apply some very, very basic code styles, for example, line breaks and indentation, you can change it from something that looks like this to something that looks like this. And now this might be a bit too small to read, but visually it has more structure now. And this visual structure can inform us as to also as to what the code is functionally doing, but also makes it very, very easy for us to see this piece of code and read it quickly and not have to bother with trying to decipher whatever hell demon wrote this thing. But this is a Python conference, not a Java conference. And as Python developers, we have some code style baked into the language already, because things like line breaks and white spaces actually do functionally affect the functional code of do actually affect the functional behavior of your code. But what about all the other stuff, the stuff that I mentioned that should be transparent to the Python interpreter, like line lengths, or when to line break in long if statements, or how to format lists? Luckily, we have a sacred text, an ancient scroll passed down to us over the aeons called PEP 8, the style guide for Python. For anyone who's not familiar with PEPs, PEPs are Python enhancement proposals, and they're a sort of RFC kind of document for Python. And PEP 8 is chock full of really wise advice on things like line lengths, when to line break, the use of trailing commas, kind of anything you could really kind of have an opinion about in Python as a code style. It was written by Guido van Rossum, Barry Warsaw, and Nick Coglan, but also contains insights from lots of other developers, for example, Donald Knuth. And it serves as a really great guide to follow. There's one section in the PEP towards the beginning that really highlights what I think is the hidden power of code styles, which doesn't seem to be discussed very much. It says that a style guide is about consistency. Consistency with the style guide is important, but consistency within a project is more important. And consistency within one module or function is the most important. And this makes sense, right? Like if you have developer A who has their own beautiful but idiosyncratic code style, and you have developer B with their own similarly very beautiful but also idiosyncratic code style, if the code in a function or a module is like flipping between the two styles, it can be difficult to read, and it can lead to misunderstandings about what is going on in the code. In some cases, it might even be worse than having no set code style at all. I like to illustrate this with an example from the previous Java monstrosity. This for loop, where it's iterating over the rows in the matrix and then the columns in the matrix. How many of you are familiar or use this convention of I and J when you need a counter in a for loop? Wow, okay, that's a lot of hands. Yeah, it's a convention that I think comes initially from Fortran, where if you had a variable beginning with I through to, I forget which number, but include J and K, it was automatically an integer. And also this convention of using I and J is also used a lot in mathematics. But the thing is, I and J don't mean anything. They don't have any semantic content. We could very easily change it to row and column, and it would make more semantic sense for this example, but it's not the convention we're used to. When we're reading this, there's a little bump as we encounter row and column, and we have to be like, row, okay, column is this, okay, row, column, okay. But when you encounter I and J, if you're used to this convention, you don't even notice it. You just read it and move on. And I think this is the kind of power of consistency in code styles and conventions. Because if you break with consistency and break with conventions, even if it makes more semantic sense to do so, it can actually slow down your reading comprehension of code. Okay, now I'd like to talk about something completely different. I'd like to talk about industrial mass production of commodities. I'd specifically like to talk about this man. His name is Henry Ford, and he's known for lots of reasons, quite a lot of them bad ones. But one thing he is notable for is this, the Model T car and the Ford Motor Company that built it. The Ford Motor Company revolutionized the way that we build cars and, in fact, kind of pursue mass commodity production in general. It did this through a process that we now call Fordism. And what Fordism emphasized, which had not really been emphasized much before, was the importance of standardization of input components into manufacturing processes. Building a car takes many, many parts, and if all these parts are engineered to the same exact standard, then you can have things like industrial production lines, where instead of workers having to be concerned about the dimensions or the specifications of the components they're getting, they can instead just focus on putting those components together because the components are standardized and as they expect. This emphasis on standardization and consistency brought about a kind of productive dynamism where tons more energy could be invested in the combination of these standardized components than there could be before. It changed the manufacturing process from a slow artisanal one to a fast mass one that kind of underpins, for better or for worse, the world of commodities that we find ourselves in today. In fact, Ford was so obsessed with standardization and consistency that when asked about the colors that the Model T car came in, he stated that you could have your car in any color you like as long as it's black. Okay, so we've talked about the importance of code styles and consistency in those code styles. And we've also talked about the power of consistent code styles. We've also talked about the power of enforced standardization and consistency. What if there is a way to marry the two things? And I'm going to shock you all and suggest that there is. There's a tool that can do this for you. It's called Black. Black is a Python code formatter tool that I've contributed to a few times, but mostly just really, really love what it's doing. It's a tool to enforce a code style upon the code bases that you write. But like, we have lots of Python code formatters. Why use this one? Is it super configurable? Does it let you fine-tune it to produce like the exact beautiful idiosyncratic code style of your dreams? No, it doesn't. It's the opposite. It's opinionated and uncompromising and has very, very little in the way of configuration. But most of all, it values consistency. When you run Black on your code, it looks the same between modules and functions and projects and teams and organizations. Black code, for the most part, looks the same no matter who is writing the Black code. This consistency in code means that you sacrifice customizability for standardization, which brings me to the slogan of Black, which is that you can have any formatter you like as long as it's Black. But how does Black do this? It does this by essentially enforcing a kind of our way or the highway strict subset of the PEP 8 guidelines. But it mostly focuses on four main components. The first component it focuses on is horizontal white space, which is where you're concerned with where to put spaces in a line and where to avoid them. Here, we basically just do what the PEP 8 says, and we just apply spaces evenly so that PyCode style will stop screaming at you. The second component is vertical white space, where we also follow the PEP 8 guidelines on, for example, which tokens to break on and how many empty lines to use. To demonstrate this, I'm going to build up a function signature that's a little too long for our line length of the screen. So we have we're defining a very nice function. We're adding a parameter A, B, a path, and a verbosity flag. And now this verbosity flag has made our function signature too long and will make it do absolutely nothing. When you run Black on this function, it will then break each parameter out onto its own line, apply a trailing comma to the last item, and de-indent the bracket after the function. This also brings it into a consistency with how we expect if functions to also look, where it breaks before the logical operator, de-indents the bracket. This has a really nice side effect of visually delimiting the function signature from the body, and in this case, the conditions of the if function from the consequences of that if being achieved. On line length, we actually break with PEP 8 here. PEP 8 has the PEP 8 has a suggested line length of 79 characters, which is tiny. It's a little bit too small. And the biggest ones that we kind of encounter in the wild can go up to like 120 characters. With Black, we wanted to kind of find a nice midpoint that's a bit bigger than the PEP 8 79, but isn't as wildly long as like some ones that we encounter elsewhere. 80 is the most popular, but as you'll notice, 80 is not significantly bigger than 79. And so we were kind of trying to decide on what number to use. Raymond Hettinger gave a really, really good talk at Python 2015 called Beyond PEP 8, which I can really recommend watching if you have any, if you want to kind of understand how to write good Python code without necessarily tying yourself to PEP 8. And in it, he suggested the best line length would be around 90-ish. We played around with this and found that 80 is pretty good, but adding just 10% more was best for reducing the number of new lines, but also kept code pretty readable. So the default line length in Black is 88. And finally, consistency. I've mentioned this a few times now, but it's good to kind of see some concrete examples of what I mean. One of those is the addition of trailing commas unless the collection fits on one line. And this addition of trailing commas is consistent throughout function signatures, lists, dictionaries, wherever this kind of pattern would pop up. It has a nice side effect that I quite like, that if you were to add an item to a collection with a git commit, the git change would show you that there's only one line added because the trailing comma already exists on the previous item. So the semantic content of your change here is entirely contained in this one line of change. If this wasn't the case, if you didn't use the trailing comma, then your git commit would look something more like this, where the previous line has been removed or changed, you've added a comma, and you've added the new one. So this is 3 lines of change for 1 line of semantic content. But if you keep things like the trailing comma consistent, then you keep your git commits to be as kind of non-verbose as possible. One thing we're also very consistent with is a very non-controversial topic, whether to use double quotes or single quotes for strings. Black uses double quotes. This is for a specific reason that apostrophes or single quotes tend to be used a lot more than double quotes within strings. For example, here, if you want to change your string, this f string from hello world I am user to hello world I'm user, you don't need to change what the string is being wrapped in, and you don't need to escape it. And it's consistent wherever strings are used, so if you run Black on a piece of code, all the strings will be wrapped in double quotes. In focusing on these 4 areas, Black implements a strict, consistent code style, informed, but not entirely adhering to, the PEP 8 guide. And you'll notice at the beginning of the talk, I put air quotes around uncompromising, because we have unfortunately compromised a little bit. There are 2 configuration options, one of which is line length. I said the default was 88, but there is a flag where you can pass your own if you really care. But you should keep it as the default for consistency's sake, please. And the other configuration option is whether or not you normalize the string quotes. We had a lot of backlash against this, and it was proving to be a very big barrier to adoption, so there is a flag to turn this setting off. But for the sake of consistency, again, you shouldn't use this configuration, and I would be very sad if you do. Okay, so I've talked about Black, but why would you use it? And I'd like to talk about some of my kind of personal experiences as someone who has been using Black now for quite a while, maybe like 6 months or so, and like what effects it's had on the way I write and read code and work with other code bases. The first is, well, code styles are one of those topics where people either generally fall into 2 camps. Either you don't really care, or you care. You really care. You care enough to have very, very long, drawn-out arguments with other people who also care, and often with people who don't care but can't leave the room. And these arguments tend to be quite circular. They don't tend to go anywhere. You never really convince anyone. But the thing is, we're not the first people to argue about code styles. This is an image of a cave painting found in the Lubang Jeriji Saleh cave in Borneo in 2018. It depicts some cattle-like animals and some hand stencils in the top right in red ochre, and is estimated to be about 40,000 years old. It's one of the earliest artistic artifacts we have of humankind. And yet, if you look in the upper left corner, yeah. I mean, it's been a contentious topic for at least 40,000 years, and some scientists even believe we've been arguing about line length since we climbed out of the primordial soup. So it's been an issue that we have yet to resolve. But by using Black, you circumvent these arguments entirely when you're working on code bases. Like, is line length X better than line length Y? Is this kind of line breaking better than this kind of line breaking? who cares? Just run black and don't worry about it. And as someone who doesn't really care too much about what code style I use, being able to bypass arguments on pull requests and things like this is a godsend. It's really, really nice. But yeah, so it can bring an element of peace to some of the arguments that you encounter in pull requests in IRC forums and stuff like this. Similarly, when I used to write Python, I would write it kind of inconsistently. I would kind of write it messily just to get it working, and then I would go back and reformat it so it looked nicer. And this is kind of a bit of wasted effort. It was quite messy. But now I write my terrible, messy Python code, and I run black, and it's now all nice and neat, and looks, importantly, the same in this file, and in the other file, and in all my other projects, and in some of the projects that I work on at work. And it looks just consistent. It's lovely. And in fact, if you use things like on-save triggers or file watchers or git commit hooks, you don't even have to run the tool itself. You can just have it as part of your everyday kind of code writing practice. And finally, consistency. It's a really pure joy to flip between one of my projects to the other one, and then to one of the Python projects at my workplace, then to another open source project that uses black, and have the code look the same consistently throughout all these projects. It really, really does speed up the time it takes to comprehend a new piece of code that I haven't seen before. And those mental bumps I mentioned where you encounter kind of inconsistencies in code style are like gone. It's really amazing. Sometimes you feel a bit like Cypher from the Matrix films where you don't even see the code style anymore. It's a really great benefit. So yeah, so if achieving consistent formatting without any of the hand-holding of a lot of other formatters forcing you sounds kind of interesting, you can install black via pip install black. It's currently meandering its way to version 1, but we're taking a while to get there because we want to make a kind of commitment that when we reach version 1, there will not be any dramatic changes in the code style that black uses. So it'd just be like bug fixes and maybe new features, but no dramatic changes. The way you run black is you can either run it against a file or a folder. Black formats those files in place, but maybe sometimes it's not what you want to do. So in those cases, you can pass the --check or the --diff. Check will not format the file in place, but will see if anything would change and tells you in the console. And then if something would change, then it would exit with an error code, which is very useful for things like pull requests, checks, or integration tests and stuff like this. Diff does the same thing, but doesn't produce an error code, just tells you like what would change. You can also run black as a daemon using blackd. Since the initial startup cost of the Python script can get in the way a little bit if you're doing a lot of blackening. So you can run it as a daemon in the background, which is exposed via HTTP port, and you can just throw your requests at it and get your code back. Yes, you can find it on GitHub at github.com/PSF, the Python Software Foundation, and black. We're used by a bunch of really cool projects like virtualenv, PyTest, PyPI, and a bunch of others, and we're currently sitting at around 12,500 stars on GitHub, which is kind of crazy. So yeah, if you have an issue or want to contribute or just check out the code, you can find it here. And I'd like to kind of round this all off with a quote from Tim Allen of the Django project that he made in a comment thread where they were discussing to use black. He says, "I've used black extensively on several projects, and much like F-Strings, the last Pink Floyd album, and Broccoli, have found I really like something I didn't think I would," which I think is a stunning endorsement. Yeah, thank you for listening to me. You can find me on Twitter at Autophagian, GitHub at Autophagy. And yes, I opened this talk by saying that code styles aren't black and white. I don't think so. I think they should just be black.
Thank you, Mika. We have time for maybe one question.
Thank you for the talk. It was great. I just want to ask, what do you think about the relation between black and isort?
Black and isort?
Isort.
Oh, I use both of those tools in the projects that I work on, but I think I have a few configuration settings for isort to make it behave nicely with black. They work well in conjunction with each other. I also like very nicely alphabetically organized imports as well. They like soothe my brain. I think they work well together. Yeah.
All right. Thank you. Give another round of applause, please. Before you're all heading down to lunch now,